Hello, third graders, and welcome to Lesson 4, Unit 4, Lesson 4. And today our focus is going to be on reviewing polygons and shapes. But first, a number talk. Let's add them up. You can go ahead and get your whiteboard and your marker and eraser and see what different strategies you can use to add 13 plus 28. Pause the video, see how many different ways you can come up with to add those two numbers, and then come back and we'll see what we can come up with. Okay, what did you come up with? When I see this problem, 13 plus 28, I think I could take my tens and add those together. Now that is not 1 plus 2. That's going to be 10 plus 20, which equals 30. Then I can take my ones, 3 plus 8, add those together, and I get 11. Add 30 plus 11, and I get 41. Another strategy that I could use is we have talked about making tens before, putting ones together to make tens. So I know that if I took 2 away from the 3 and gave it to the 8, I would have a 10, which means I would have 1 left. Okay, so then I can take the 10 from the 13, the 20 from the 28, the new 10 that I just made, and my extra 1 that's left over, add those together, and also get 41. All right, good job. So now you can erase your whiteboard. You can write down the answers to these problems really quick. 2 times 4, 3 times 4. 2 times 7, 3 times 7. And we're going to talk one more time about helper facts. Now, we know that if we know a problem like 2 times 4 is 8, but I need some help with 3 times 4, well, I could make an array for 2 times 4. Okay. And then 3 times 4 is one more group of 4. So I don't necessarily need to make that entire array for 3 times 4. I just need to add a group. And I know that if this is 8, I don't necessarily need to count all those x's again because I already know it's 8. I just need to add my group. So 8, 9, 10, 11, 12. Okay. So 2 times 7 is 14. What's 3 times 7? Now I could make an array again like I did in the example above, but if I know that 2 times 7 is 14, 3 times 7 is going to be one more group of 7, so maybe I could just add on 14 plus 7, and that's going to be 21. It's another strategy to use helper facts. Here we have 2 times 8, which is 16. 3 times 8 is going to be one more group of 8. So let's make my 2 rows of 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. That's my array for 2 times 8. Now I have 3 times 8. So I'm going to add just a group to that original array. I add a group of 8 because I'm going from 2 groups of 8 to 3 groups of 8. I know the orange is 16, so I'm just going to add on my last set of 8. So 16, 17, 18, 19, 20, 21, 22, 23, 24. 3 times 8 is 24. 5 times 7 is 35. That is a great helper fact. So if I have 6 times 7, that's going to be one more group of 7. So I could just add on 35, 36, 37, 38, 39, 40, 41, 42. 6 times 7 is 42. Now, could have I made an array for 5 times 7 and then added a row for 6 times 7? Absolutely. All right, one last set of problems. 10 times 6 is 60. But I have 9 times 6. So I'm not adding a row. I'm going to subtract a row or subtract a group of 6. Yes, I can make that array for 10 times 6 and have 60. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we're making 6 in each row to make 60. So I'm going to pause and finish that. All right, I have my array for 10 times 6 finished. I have 60, but my new problem is 9 times 6. So I'm not going to add a group. I'm going to take a group away just by simply crossing off that last row. Now I can go ahead and count all those X's to figure out what 9 times 6 is. Or if I know that I had 60 and I'm taking away 1 6, a row of 6, then I can just think of what's 60 minus 6. 60 minus 6 is 54. Our last problem is 10 times 8, which is going to be 80. I have 9 times 8, which means I'm not adding a group. I'm subtracting a group of 8. Okay, of 8. I could make an array for 10 times 8. But if I know that 10 times 8 is 80, and I'm going to take away a group of 8, it's going to be 80 minus 8, which will be 72. Okay, I want you to get out your math journal and turn to page 110. Pause if you have to go and get it, and have a pencil handy. So, for number 1, I want you to look at the 4 shapes below. Circle the shape that does not belong, and then tell why it doesn't belong. Explain your answer. You're going to do the same thing for number 2. Look at the 4 shapes, circle the shape that does not belong, and then explain your answer. Explain why you circled that particular shape. Okay, you should have the same 2 shapes circled that I do. And here's why I circled those particular shapes. Well, the shape that I circled for number 1, it's not closed. There's an opening right here, okay? All the others are closed. All their sides touch. And the other shapes all have straight sides, where this one has one curved side. So that's why that one, I feel, doesn't belong. The second one, I circled the second one in the row. And my reason was this shape has sides that are crossed. Right here, they touch each other, they crisscross. The other ones don't. And the other shapes are all closed. This one has an opening. So that's why I feel those shapes do not belong. Okie doke. So we get to the next page. In your folder, you should have these shape cards. I want you to pause the video, cut them out neatly, and be ready to use them when you come back. Now that you have those cards cut out, we're going to play a little game that's called What's My Polygon Rule? Now, a polygon is a figure excuse me, that is made out of straight sides and it's closed. So for example, if we look at this poster right here, which we're going to come back to in a little bit, these are polygons. Most of these are polygons. Triangles are polygons. Pentagons are polygons. Hexagons are polygons because they have straight sides and they don't have any openings. All their sides touch and they're not curved. So a polygon has straight lines. It's a closed figure. It's not curved. It's not a circle. So we're going to go back to my game here. that's called What's My Polygon Rule? I already have 2 shapes in my circle. Now down here, I have that you can draw a large circle on your whiteboard and you can follow along with me. So in your circle, you can go ahead and put in shape I and shape A. Okay? And then I have shape G on the outside. It does not go in the circle because it does not fit my polygon rule. So I want you to take a look at shape I and shape A. Compare it to shape G. See if you can figure out why G doesn't fit my rule and can't go inside my circle. I'm going to give you some more clues. I have some more cards that I'm going to put inside my circle because they fit my rule that I've come up with for the polygons to be able to be inside my circle. Shape R can fit inside my circle. It can come join the party. But G can't. Why can't G? Shape Q can come in and join my party. But G can't. It doesn't fit my rule. Shape M can come join my party. But G can't. It doesn't fit my rule. Shape J can fit into my circle because it follows my polygon rule. But G doesn't. Why do you think? Did you come up with a reason why G can't come to my party in the circle, but all the other shapes can? Look carefully at my shapes, at A, I, R, Q, M, and J. Look at their sides. Look at the length of their sides. So when I look at A, all 3 sides are the same length. And J, all 4 sides are the same length. And Q, all 4 sides are the same length. All the sides in all my shapes inside my circle are the same length. But G is not. It has 2 sides that are the same and 2 sides that are not the same length. So G does not fit my rule. So this is an activity that you can play with some friends or family members at home. Pick a couple, decide what you want your rule to be, put that shape or those shapes inside your circle, pick a shape that doesn't fit your rule, and see if you can have people try to figure out what your rule is. Here's a game to play, multiplication draw. Here are the directions. Remember, I'm sending a deck of cards, so you should have cards. Sorry about that, the phone rang. So I was just explaining that this is a game that you can play, that you need number cards that I'm sending home. You should have those already. And there's a record sheet for you to use in your folder. This is a little poster of some shapes, mostly polygons. And the ones at the bottom are not polygons because they don't follow the polygon rules of having straight sides, of having closed figures, of having nothing crisscrossed. Even this one here, this diamond shape, is not a polygon because it has that line in the middle. Okay, so polygons, some of them have right angles. That's when you see this blue circle, or that I circled that blue square. That means that that shape has right angles, and I always tell the boys and girls that's because when you look at those angles there, it looks like a capital L. Another word I have here is parallel. Parallel is when you have sides that are opposite and they're running side by side, and they're never going to connect. They're never going to crisscross. So some of our pentagons have parallel sides, parallel lines, parallel sides, because if we would extend those lines and extend those sides to keep them going forever and ever and ever and ever, they are never going to crisscross. They're closed figures. Some of them have equal side lengths. There's lots of parts to polygons. So Math Journal page 111 will be your work for today. Have a great